Welcome to the Observable Lightning Talks of May, because we are the 24th. Oh, no, it was May, but at the end, we end up scheduling it on April. So it's, I would say, it's the second Lightning Talks of 2024. So welcome to this Lightning Talk. Very excited to organize this event again. And we have a couple of interesting speakers. So for those who are connected and never had first experience with the Observable Lightning Talks, let me briefly explain how this format works. So first of all, you may have this coming from Twitter, LinkedIn, YouTube, wherever this event has been broadcast to. So which means you can interact with us because it's live. So you have the chance to drop your questions, to say hi. Maybe you can also say where you're connected from. Though I'm connected from south of France, so let us know where you're coming from. And during this live stream, we will have a couple of speakers that will present a very thought leadership content about, of course, observability. We expect that for sure. And at the end, we will have a panel discussion. So in order to respect the timing, all the Q&A will be managed at the end through that panel discussion. So the Observable Lightning Talks, like I said, how it works, three lightning talks, so 3 times 15 minutes, no Q&A. And then at the end, we end up with this panel discussion. So type your questions, write your questions in your social networking solution, and we will answer those questions later on. And of course, I will take advantage to ask my own questions because I always have questions depending on the topic that has been presented. So for today, I'm very excited because I have a really nice lineup today. So let me present the agenda for tonight. So we will have Yarden Laifenfeld, which is a DevRel working at Dynatrace, a software engineer. She used to come from the Rockout team, so she knows a lot of language skills, really developer focused. So she also organized a couple of conferences. So she's going to talk about the tips to drive developer adopt observability. So very interesting because I think somehow when we want to implement observability, we get challenges to adopt observability by our developers. Second speaker will be Vijay Samuel. So if you follow observability in general, you may have heard about Vijay somewhere. Vijay is working for eBay, and he is an architect. Now he's been driving the observability stack using cloud native technology. So very interesting to hear about Vijay's presentation, especially because it's going to basically walk us through how to basically take Prometheus to a planet scale. So we're going to see how we can scale Prometheus, especially if you have a lot of metrics to manage in your environment. And last, we will have Adiana, Villela. So same thing, if you follow LinkedIn and you follow OpenTelemetry or Observability, you may have heard her name somewhere. You may have heard her in the various conferences. In KubeCon, she was presenting. She is part of the OpenTelemetry end user SIG, very active. So very excited to have Adiana in the Observable Lightning Talks. And she's going to cover an OpenTelemetry related topic. So introducing OpenTelemetry to your organization in 3 steps. So if you want to adopt OpenTelemetry in your organization, you don't know how to start, listen to Adiana. It will be very interesting to hear more about this. All right, so that's the agenda for tonight. So I suggest to jump into directly the first presentation, and Yarden will be the first ones presenting. So let's go. Hello, Yarden. How are you?
Hi, I'm good. How are you?
I'm very good. So where are you connected from today?
From Israel.
Israel.
Very hot here. Yeah, I see her with a sweater. It's the exact opposite here.
Yeah, it's kind of starting to be nice, but we have still some wind. So wind here in south of France can cold down the sun that the heat from the sun. So, but but behind this sweater, I have t-shirts.
You're
Uh,
ready for the summer.
I'm almost ready for the summer for sure. All right, so I introduced. I will leave you have briefly introduce yourself. So I may expect that you will introduce yourself to this session. So yeah, 50 minutes. The stage is all yours, and I will note some questions and ask questions later on during the panel discussions. All right, so good luck and see you in a few minutes.
Thank you. Yeah, hi. So I'm going to talk about tips to drive developers to adopt observability. I'll start by introducing myself. So I'm a software engineer and a developer advocate at Dynatrace. I did join from Rookout, which was a small startup, which Dynatrace acquired a few months ago. And one thing about me is that I really love tools that are by developers for developers, and I love them as a developer to develop these kinds of tools. So I'm so lucky to do that, and then to also meet the users of what I'm developing and have discussions around that. And then also to be on the other side, to be a user, to use packages or frameworks or tools, and then also meet the people who are behind them. So I love both sides of that, and that's why I love talking about developer observability. Now, when I say observability, usually we kind of think of things like SLOs, maybe monitoring, right, when is our app up or down, metrics around that, distributed traces, so we can maybe nail down issues into which service they occurred in, or maybe even things like automations and releases, or things that happen once our code is actually deployed into production or other environments. But the thing is that if we look at all these, like there's so much packed in here, but none of these really relate to developers. Most of them aren't really relevant or aren't really interesting, and your average developer won't really be looking at these. So why do developers need observability? Well, we like to think of developers as coders, right? As people that kind of like sit in the dark and just code away and add more and more code. But most of the time, developers aren't adding code. They're looking at code, they're seeing what's happening in production, for example. Maybe they're looking at security aspects or testing or just researching or reading other people's code. So this notion that developers are just writing code is wrong. And a big question that developers ask themselves often is what's happening in production. And the reason they ask that is usually because a bug happened, right? A bug happened to a user experienced something that they shouldn't be experiencing, and now we have to go investigate. And for that investigation, we need observability. We need to be able to see what's happening, not on our local machine and not somewhere we're familiar with, but on this remote machine where we may have tons of instances. So many things can be happening at once, and we need to be able to observe what's happening there. So developers need observability too. But there is an issue, right? You may be saying, just set up a developer observability, right? Pay a company that does developer observability, get a tool, set it up, and that's it. You have developer observability. But this is just where the problems start. So the issues stem from these two basic reasons. First of all, there's lots of new tools, especially as developers. We're seeing new frameworks, we're seeing new languages, we're seeing new packages all the time. And I'd say more than 10 a week. And for each of these tools, we have to quickly make a decision whether we want to see what this tool is all about, or we want to move on to focusing on our current task. So we keep hearing about these tools, we keep having to make this decision. And even the tools that we do choose to go forward with, they don't always stick. So we may try something out a little bit, and then we find out that it isn't really the right tool for us, or it's just not that interesting. We don't need to use it that often, so it doesn't stick. And this is fine. Both of these things are great. There's tons of people doing tons of different things, and a tool that I might not need to use, someone else might find great use for. So this is great, but it does lead to a few issues, and it does kind of lead to this 3-stage process when developers adopt new tools. So the first stage is to assess quickly, which is to quickly decide whether we're interested in really looking at what this tool is all about, or we want to move on. After we've decided, we want to try it out, really make sure it's for us. And then once we've decided that it's for us, we developers, we're usually maybe a bit stubborn, and we stick with it. So no matter what, we're sticking with that tool that we already decided that that's the right tool for us. Now, since we want to have developers adopt observability tools, we're going to look at each of these stages and see how we can succeed in getting our developers to adopt our tools for these stages. So for the first stage, the assess quickly stage, it's not just assess, it's assess quickly. And it's quickly because it's usually a matter of minutes, hours, most likely less than a day. And the reason that it's done so quickly is that we have this tool fatigue. So we have all these new tools. We're always hearing about something new with some cool new name. And at some point, we're just tired and we don't want to put in so much effort into learning about all these new tools. So we do it quickly. The second reason is that it's almost never the main task. Developers are almost never tasked with learn about this tool, find out if this tool is the right tool for us. I've heard of a lot of times that DevOps get these kinds of tasks, but not really developers. And so developers have to make the time to look at them, and that's why they do this assessment so quickly. And the third reason, obviously, it's a lot of work. No matter what tool you're introducing, it's going to be work to learn when to use it, where to use it, how to use it. It's not just using it. It's not that easy. Now, the solution to this is pretty straightforward. First of all, we need to choose wisely. We need to make sure we're not throwing a ton of new tools at our developers all the time. So if you're a manager, if you're making these kinds of decisions of what tools to add for your developers, make sure you're not constantly switching it up, constantly adding new things. Secondly, make sure your tools are effective. They're effective for your problems, for your issues. And third of all, show the use. Developers love knowing how to use or what's the use of the tools that you're going to show them. So it's important to practically show them on issues that they have. Now, I do want to dive a little bit into the ensure effectiveness part. And I gathered some questions here to kind of gauge whether or not this new tool that we're talking about is effective or not. So these questions are, does this tool support all our technologies? So if you're, for instance, using more than one language, you'll want to make sure that you're using one tool for all the languages and not having to introduce multiple tools that do the same thing for different technologies. Does this tool integrate with other tools we already use? Because if it does, there's a much higher chance that developers are going to easily start using it if it already integrates with tools they use. And how hard is it to get started with this tool? And I'm not talking about some advanced use cases. I'm talking about the most simple thing that you need to use with this tool. Does it require a lot of setup and hours of understanding and learning just this specific tool? If so, developers are less likely to actually want to get started. Now, specifically for observability tools, I would ask these two questions. If we had this tool in the past, would we be more productive today? And I mean, very, very practically think of a situation where this observability tool could have come into use. And if you had it, you would have been more productive. And if you can't think of such a situation, it's probably just not the tool for you. And if you can, great. And go tell that to your developers. Tell them about that specific case, and it'll probably convince them. The next question is, does our average developer understand the use for such a tool? At the end of the day, the tool is there to solve a problem. You don't start using a new tool just because there is a new tool. You start using a new tool because it's there to solve something that's already bothering you. And the question is not if it's bothering your most senior staff, principal, engineer, but if your mid-level, senior level engineer is experiencing this problem, it probably means that almost everyone in the org or in the R&D department is experiencing that problem, and that it's going to have a wide adoption in your organization. So once we've ensured effectiveness and we've gone through these stages and we've made that initial, yes, I want this tool sounds interesting, we got to the stage of try it out. And I'd say this stage takes about a week or so. And in this stage, we need to create a habit, because even if I initially thought this tool was cool, this tool would have helped me, but I didn't use it on a daily or weekly or whenever something happened, I didn't use it, I just forgot about it. And when I actually needed it, I probably didn't even remember it existed, didn't remember I'm paying for it, didn't remember what it's for. And so even though I had it, it doesn't help me. So we need to make sure we create a habit. And this habit should be either daily or weekly in use, or when a specific use case comes up. For instance, if you have a security tool, then you want to make sure that every time you have a security issue, this is the tool you're going for straight away. The second part, very important part of this phase, is to have no bad experiences. And it's hard to ensure that there are no bad experiences, but there are things that we can do to ensure a more positive experience. And once that experience is more positive, it's more likely to become a habit to use this tool. So in order to make this stage successful, I have these 4 tips. First of all, have a champion. So have someone, an experienced engineer on your team who likes this tool, who knows this tool, who can advocate for this tool internally, and who can share success stories. These success stories will very easily drive other developers to try this out when they're in a similar situation. Secondly, we might want to reward people driving adoption, and we might want to build tasks around the tool. So look at your backlog, maybe tasks that wouldn't immediately come up, but they do relate to using this tool. Maybe you should use them now just to get into the hang of using that new tool that you're talking about. And fourth of all, make sure it works. Make sure it works may sound simple, but it's making sure that these 3 steps are set. So first of all, configuration. Make sure it's configured to your specific case, to your specific use. Secondly, make sure everyone's onboarded, they know how to use, they know the features that you want to introduce them to. And third of all, make sure everyone has their own setup so they can use it on their own individual computers and not just in the demo environment for the onboarding. But when they actually need to use the tool, they'll be able to use it straight away and they won't have this extra steps in order to get it started. So once we make sure it works and we've ensured this positive experience, we're on to the next stage, which is to stick with it. Now, what this means is that we've successfully introduced a new tool to our developers, right? They've assessed it, they said yes, they tried it out, it was a good experience, they want to stick with it. And at this point, if you introduce a different tool, they might say, wait, no, I'm so used to this tool, I like this tool, I don't want to change it up. I know that I've been in that situation, and probably every developer out there has. And this is good for you, because if it's a new tool and you wanted your developers to use it and they're using it, that's great. But consider this. First of all, there may be a situation where you need to switch to a new tool. So that can be for a variety of reasons. If it's for a lack of features, or if the pricing has gone up, or for any other reason, you might want to switch to a new tool that does similar things. Or this also happens all the time. You're hiring new developers, and these developers are used to a different tool. And so they're with this mindset of, I'm sticking with my previous tool, and now you need to convince them to change to a new tool. And this is going to be difficult because change is hard. As humans, we inherently resist change. We don't like changing the way we work. We don't like changing the tools we use. And this change also requires work. It's not going to be just like one day I wake up and I use a new tool. I'm going to need to learn how that tool works. And that's work that we might not want to put in if we already know a different tool. And this may sound weird, but better the devil we know than the devil we don't really applies here. Because even if we have a tool that is working less than we want it to work, that has specific incidents or bugs, if we're used to those and we know to expect them and we know our ways around them, then we're going to want to stick with that tool and not have to learn all these quirks of a new tool. Because we come with this assumption that almost every tool is going to have these quirks. And if we already know them, it's much easier. So these are the reasons it's hard. But maybe we can make it easier. We can make it easier by making the transition gradually. So instead of just introducing a huge tool with all its features and going through a 3-hour long onboarding session, introduce one feature at a time. Introduce the most important thing at a time. Make sure the onboarding is quick and efficient. Also have workflows in place. So if you already know ahead of time that a specific thing is going to happen again and again, and this tool is going to be used again and again for the same thing, have that workflow in place. Make sure to teach that workflow and make sure that it's easy and accessible to all your developers. And third of all, have a support network. If that's documentation for the tool, tutorial videos, or a place to ask questions or to chat with someone who's actually using the tool or developing the tool, that will make adoption much more successful, because if people feel like they can rely on this tool even when it does have those quirks, they're more likely to accept it. Now, this may sound like a lot, and it kind of does sound like we need to plead with our developers to accept this new tooling. But at the end, our point is to have these developers want these tools. If they don't want the tools, they'll just not use it. So we want to make everyone happy by using these tools, and always keep these benefits in mind. Once we have these observability tools in place, we'll have better understanding of production environments. Our developers will have more data to easily solve issues, and we'll have a quicker fix time. So this is not just for the developers, this reaches all the way to your end users. But at the end, you will have happier developers, which is, I think, the ultimate goal for everyone. So thank you. Thank you, Henry, for having
All
me.
right. Thanks a lot, Yarden. I have a few questions, but I will keep them for later. I already have some because I listened to a talk at KubeCon, and I thought it reminds me of a few things. So I will ask them later. So thanks, and let's introduce the next speaker. So I will launch the small transitioning, and see you in a few seconds. Hey Vijay, how are you? I cannot hear you. Hello.
Sorry, I was on mute.
Yeah, you're on mute.
Hey, Hendrik, how are you?
I'm good, very good. So I don't know where you're located, but you have a nice swimming pool behind this virtual background, I would say.
Yes. I'm based off of San Jose,
San Jose.
California.
So is it same thing? The summer is slowly coming to San Jose, or is it already there?
Last week was pretty warm. This week, again, it's a bit chill. Hopefully, the warm weather starts coming in. I'm more of a summer person.
So last time I met Vijay was at KubeCon Paris, and I was astonished because there was Scale. I think was at the beginning of the week. I think there were conference, and so Vijay were speaking at Scale, then flew over to Paris, arrived in Paris jet lagged, and then delivered his talk in KubeCon. So yeah, very very impressive for that, for sure.
Thank you.
All right, so I'll leave you on stage, and very eager to hear how we can scale Prometheus. So very eager to hear more about your use case and your story. So see you in 50 minutes.
Sure. First of all, thank you, Hendrik, for the time. As stated, my name is Vijay Samuel. I'm a principal architect at eBay, and I help run the observability platform. And this is one of the topics that's very near to both me and folks in our team. How to take Prometheus planet scale. It's something that we have been working for the past couple of years, and a lot of interesting lessons we were able to take out of it, and the results that we got out of it was pretty impressive as well. So I'll spend the next 15 minutes talking about that. We always like to talk about our scale. We have roughly 7 billion time series that we ingest into our platform, which translates to around 69 million samples per second, which again translates to 3.1 million Prometheus endpoints that are being polled at any given point in time. And the data that's been stored is being queried at a rate of 16,000 queries per second. And this is being used for various things like ensuring that the site is up and running, all our rollouts are being done in a health-aware manner, monitoring our infrastructure, so on and so forth. How did we solve for scale? One of the things that I've become a big believer through my journey as an architect is that architecture is all about common sense. Architectural patterns are all around us, whether it be in nature, day-to-day activities that we perform, or even as simple as that book that you refuse to read in undergrad. And I strongly believe in building what you observe, and observing simple things like an interesting white paper that you read, an optimization that was staring right at you that you are so oblivious to, or the new open source project that caught your eye. So that being said, like a few years ago, there was this white paper called Google Monarch, and we looked at it and we found that there are a lot of lessons to be learned from that. But before we go into the more complicated things, let's take a simple lesson in distributed systems. What is a simple TSDB? You have one instance and you're writing all your time series into it. You can take the stock Prometheus as an example, either through polling or through remote write. You pump in all the time series into that. Next, you want to scale horizontally. What do we do? First, we shard. Instead of having one TSDB, we have n TSDBs. You put an ingester in front of it. It knows how to apply a very specific algorithm, maybe simple dimension based shard hashing. Take a series, mod by the number of instances, pick one, and then write into that. And this is a reproducible activity that you can do to the point where every sample of a given series always falls into a single TSDB. Next, we want to replicate. Okay, all my data is within a single region. So what do? I add two more regions, same number of shards, and ensure that when I write, instead of writing into a single region, I do a fan out write across all of them. So now I have replication. And finally, we cluster. So we cannot infinitely keep growing horizontally. So what do? We add different clusters and say that samples of one tenant go into the green cluster, samples of another tenant go into the red cluster, so on and so forth. Now, one thing to note about this is that, like, if we were to have 7 billion worth of cardinality, what would happen is that we would stick all of this cardinality into all three regions and make sure that when we are querying, we have to query at least two of them so that we can do streaming merge dedupe. So you are always pulling data out of two full regions. So what we ended up doing after that is do a bit of modified clustering. So we looked at all the data and we decided, okay, we need to keep it as close to the source as possible. So if a Kubernetes cluster sits in region B, AZ1 or AZ2, we make sure that we have a few TSDBs that are sitting within these AZs, and all the clusters within this region, their samples are collected only within these AZs and replicated within them. And anything that we can roll up, say dropping the pod label and things like that, we store them on TSDBs that are localized to the region. So you have different region-based clusters, but you can see that the green clusters are replicated across all the regions. And what do we need to do after that? We need to make sure that you know exactly where the data is sitting so that you're able to query it the right way. So query comes in, the querier knows exactly that it's sitting on shard 4 in AZ2 and shard 1 in AZ1. So I'm able to get the right responses. So how do we know exactly where the data is sitting? This is one of those data structures that we tend to overlook. So you can have something called a field hint index, which the Monarch white paper prescribes, which is in simple terms, it can be Bloom filters. So every time a new series comes in, we generate engrams and fingerprints for them and store them in what is called an index store. And this index store makes sure that we have fingerprints of every key value pair of the Prometheus labels that are there, along with engrams, and they're stored so that when a query comes in, we exactly know, okay, this label key value pair sits on XYZ shards. And typically we use what are called trigrams. So there's an example of what trigram would look like for, say, example. And for different kind of labels. We did some experimentation and found that maybe trigrams is not better for something like a pod name. A 4-gram might be better and things like that. So if you put all this together, we came up with what a layered approach where you have leaf, zone, and root. A leaf can be something that is localized to a Kubernetes cluster. A zone is a layer rolled up on top of that, and root is even a higher level, and that's where all the user queries come in. And these are basically composable tiers. So if you put a query on top of the leaf, and you're trying to visualize on top of that, it's a fully independent setup. Similarly, an AZ level zone is fully independent, and the root is a combination of all of them. And end users really don't know where they are coming through, because they are able to see all the data. So from an architecture perspective, this is how it looks. So on the leaf, you have the entire stack. If you have used things like Cortex, this might look familiar. We have something similar internally, which is based on the Prometheus storage and all the public interfaces that the Prometheus source code provides. So we have the TSDB itself, which is Prometheus. We have an ingester, a querier, and the new component, the indexer that we put in. The TSDB make sure that all the field hint indices are being propagated to the indexer, and the querier is basically using that. And the querier can be used for both visualizations and also the ruler, which basically applies recording rules and whatnot, writes them to either an alert manager, writes both to an alert manager and to the ingester. And you also have the long-term store, which is object store based. So the next is the zone, and what you can see is that the indices are propagated up to the zone. So if a query comes in through the zone, it has view of everything that's within the zone and also the leaves that are connected to it. So the queries can propagate downwards as well, and you can keep adding as many layers like this. So from ingest routing perspective, anything coming into the leaf directly comes through the leaf ingest, zone for the zone ingest, and root for the root ingest. And for zone and root, you can see that there is um, cross zone replication that, or cross region replication, that can happen. Query is where it's interesting. As I mentioned, the field hint indices are propagated upwards, and when a query comes in, it first checks with the root index. The root index will let it know that it needs to go to the zone router and put specific zone querier. The zone querier will again ask the zone or the leaf indices, and once it knows which exact TSDB to get the data from, it gets it and then propagates it upward. One of the other questions that we typically ask is that, okay, Prometheus, we cannot store a lot of cardinality. Is there a way in which we can shave off all the excess cardinality that's there? And what we ended up doing for that is supporting aggregations. So what we have noticed is that certain series are or certain raw series are never queried, especially tell me the CPU usage of a very specific container ID. These are questions that are never asked, but we have the ability to ingest all those labels into the TSDB. So for these kinds of labels, it's better to aggregate them into granularities that are in fact queried. So what do we get out of this? It cuts the amount of CPU and memory utilization on the TSDB, but also when we do it in a streaming manner rather than using recording rules, which more conventional wisdom teaches us, it additionally cuts down the cost of doing these aggregations down by 90%. So what we do is, when a series comes in through the ingest endpoint, the ingester, if there is no aggregation policy, it just puts it directly on the TSDB. Otherwise, it basically routes it into an aggregator where the aggregation happens, say, over 1 minute windows, 2 minute windows, and the aggregate series gets written into the TSDB, and all the raw series are dropped on the floor. Is there a way to speed up queries? Is the next question that we might ask. So we did a couple of optimizations. One is query pushdown. So in a layered approach or even a clustered approach, we try to bring all the query samples down into the query node. But rather, scatter gather is a known pattern that has worked for several years. So something similar can be done while evaluating these queries as well. The other thing that we can do is projection. Every raw label key value pair does not need to be returned back into the query node. We only, depending on what the query is asking, say group by pod comma namespace, we ideally need only pod and namespace to be sent back. And the observation was that the CPU and memory usage is far lower when we are just sending the required labels along with the series hash rather than sending everything together. Here's an example of how it would look to do a projection. If someone is doing a very common question, how do I get the 90th percentile of something by cluster? So the sum rate is something that can be pushed down. So from root, it goes to the querier, zone querier, and to the leaf. And on the leaf, you pull the raw series, evaluate, put it back to the querier, and the zone querier, and the zone querier again puts it back after another level of aggregation. So you have the aggregated series for the sum rate, and only the histogram quantile is being evaluated on the root. So in summary, our building blocks for scale to get Prometheus operate at the level that we do right now. First is clustering. Second is request routing, aggregations, and push downs and projections. Thank you.
Awesome. Thanks, Vijay. And you finished even earlier than expected time, so 13 minutes instead of 15. Wow, amazing job. I have a few questions, but again, I will leave it for later. And especially there are a few concepts, because I'm not an expert in Cortex. Maybe it will be meaningful to remind a few aspects of later on with the attendees. What are how you do this aggregation? You mentioned about aggregation, but we'll talk about it later on.
Okay.
All right. So thanks, and see you in a few seconds for the next speaker, which is Adiana. Hey, Adriana, how are you?
Hey, I'm good. How are you, Henrik?
I'm very good. I for those I saw Adiana last time. Was it in KubeCon Paris? Because you were running all those Hotel of Humans, and you were speaking there with Lise, I think, at the Observability Day. So, how was your experience so far at KubeCon Paris?
Oh, it was great. I mean, it exceeded my expectations. And, Reese and I are talk buddies now. We've done like 3 talks on observability at 2 KubeCons so far. So it's been awesome. And Paris, honestly, was like the best venue for a conference.
It's surprising because usually people is not saying that Paris is a great areas for this, but
I had such a blast.
Otherwise, if for those who never heard about Adiana, she also has a great podcast called Geeking Out. So the QR code is here. Check it out. It's out there. There is, I think you invited recently Alex Bowden, and I think it deserves to be listened because really good conversation for sure.
Yeah, thank you.
All right, so I'll leave the stage to 15 minutes to present. So good luck, and see you in 15 minutes then.
All right, thanks. Well, hello, everyone. Welcome to Introducing OpenTelemetry to Your Organization in 3 Steps, and super happy to have you join me here today. Now, before we get started, let me introduce myself. So my name is Adriana Villela, and I am a CNCF ambassador. I'm a 3rd-year HashiCorp ambassador, blogger, and podcaster. By day, I am a developer advocate in the observability space, and I spend a chunk of my time working in OpenTelemetry. And like Henrik said, I am one of the maintainers of the OTel end user SIG, and by night I climb walls at my local climbing gym, and I also love capybaras. So this AI generated image kind of just perfectly captures me. So while sadly I won't be talking to you about rock climbing today, I will talk about something that's near and dear to my heart, which is OpenTelemetry, and there will be capybaras involved. So picture this, you're sold on observability with OTel, which is amazing, and you're super excited to bring it into your organization. And maybe there are even some teams already using OpenTelemetry in your org, but they're all doing their own thing. And you need an overall strategy around rolling out OpenTelemetry so you don't end up with a bunch of little kingdoms doing their own thing, but you don't really know where to get started. So the question is, how do you go about it? Well, today I will share not one, not two, but 3 steps to help you get going. So step 1 is communicate. Seems obvious. Now, folks in your organization won't know that you want to use OpenTelemetry until you tell them. And this is where a little advocacy goes a long way. So rolling out OpenTelemetry across an organization is a huge initiative. And by declaring that OpenTelemetry is happening, people in your organization know that it's serious, especially when the directive comes from leadership. So, make an announcement through a combination of Slack or Teams or whatever collab tool you have in your organization. Mention it in a town hall. People don't want to just be told what to do, though, because transformation fatigue or initiative fatigue are very real. So you must explain what OTel is. And if you want people to follow you down this path, you need them to know what they're getting into. So explain what OTel is and its benefits. So let's look at some of the benefits. Well, benefits include no vendor lock-in. So if you become unhappy with your observability vendor, no problem. It's relatively easy to switch to a different vendor without re-instrumenting your code, which is a really big deal. It's also vendor neutral because OpenTelemetry is vendor neutral, it means that you can easily send telemetry data to multiple observability backends simultaneously, which is a great opportunity for you to do a side-by-side comparison of observability vendors to see which one suits your needs. Also, OpenTelemetry is active. It's actually the second most active CNCF project behind Kubernetes. Now, OpenTelemetry is also standardized. So it means that it is backed by most major observability vendors. So it is here to stay. What we love about OpenTelemetry is it allows you to correlate all 3 key telemetry signals, i.e. the 3 pillars, the traces, metrics, and logs, which its predecessors didn't enable. Now, you'll also want to put a call out to folks who are interested in OpenTelemetry. Recruit them to be your champions and consider forming an observability practices team with them. Now, this can serve as an advocacy team focusing on the benefits of OTel, creating practices around its implementation and rollout, and it allows these folks to become subject matter experts in OpenTelemetry. Include engineers who can dig into OpenTelemetry to produce a set of practices with the organization and to become the go-to folks for any OTel-related questions. Recruit a mixture of individual contributors and managers. They don't all have to be OpenTelemetry experts. They can grow into that. They just need to believe in it and want to help roll it out. And finally, create an OTel rollout plan with milestones and dates for reaching them to demonstrate your commitment to the project. You don't want just some wishy-washy project where no one really knows, well, it's happening, but is it really? So make sure your timelines are realistic by getting input from your engineers and managers. Don't do this on an island. Have them work with your observability practices team to put a plan in place and then communicate the plan. And during this planning, you might want to ask your engineers questions such as, what are the critical path transactions in the system? What information is most important to you for troubleshooting an issue? And how can we help you adopt OpenTelemetry? Step 2, do your homework. You need to understand your system's landscape to put your plan together accurately. So your application code probably comprises multiple services. So you'll want to identify each service and dig in. So for each service, find out or take inventory of the language that it's written in so that you can determine what OTel instrumentation library or libraries your dev teams need to use. Also, it's just kind of nice to every once in a while, like take stock of like, oh yeah, these are the languages I use in my org. Who'd have thought? Also, take inventory of any third-party frameworks and libraries that you're using, since OTel auto instrumentation is available for many popular libraries and frameworks. These include things like Python Flask and Java Hibernate. And finally, identify your homegrown frameworks and libraries, and I'll talk more about that shortly. So next, you'll want to dig in a little deeper to identify your most critical high-value transactions. You'll want to instrument those first because, according to OpenTelemetry co-founder and my fellow colleague, Ted Young, it ensures that complete traces are being created and you can start to investigate important issues early without having to wait for the entire organization to complete their migration. You'll also want to find out if any code has been already instrumented, and if so, what instrumentation frameworks are being used. And that's kind of an interesting little investigation. And as an aside, I can't tell you the number of people at a past life when I was doing this actual work. We'd say, hey, did you is your code instrumented with OpenTelemetry? And they would say, yeah, it's instrumented with OpenCensus. Not the same thing. So find out if it's using OpenCensus or OpenTracing or something else. OpenTelemetry is backward compatible with OpenTracing and OpenCensus, so you don't have to make any major code changes initially. However, you'll want to plan to eventually migrate over to OpenTelemetry to take advantage of all that it offers. So for example, OpenCensus and OpenTracing don't support logs and metrics or the integration between traces, metrics, and logs. Now, if you're using any homegrown libraries or frameworks, be prepared to re-instrument your application using OpenTelemetry. Mentally prepare yourself. It is an undertaking. Now, along with the application tracing data, you'll want to send metrics data to your observability backend for a nice holistic systems view. So again, you have to identify those metric sources. Is it Kubernetes, Kafka, Docker, Nomad, virtual machines? Also, ask yourself, like, what application metrics do you want to capture? And then finally, step 3, instrument. So you're ready to start instrumenting with OpenTelemetry, and here are some recommended instrumentation practices to help teams get started. So first, if your system is experiencing frequent reliability issues, this is usually a sign that you need better observability. Therefore, you need to delay some planned features to instrument your code or reevaluate what's already been instrumented. And as I always like to say, if you're building a house and the house is on fire, you do not continue working on the bedroom, you put out the fire first. So if your language supports auto instrumentation, you'll want to take advantage of it. This is a pretty low barrier to entry into OpenTelemetry. And currently auto instrumentation is available for Java, .NET, Python, JavaScript, PHP, and Go. That being said, it is possible to over-instrument, which means that you can end up with so much crap that it essentially becomes hard to troubleshoot issues. And this can happen, unfortunately, from auto-instrumentation. So once you start auto-instrumenting your code, take a step back to see if the libraries being auto-instrumented are the ones that you need to collect instrumentation from. Now, fortunately, various languages that have auto-instrumentation capabilities also have the ability to pare down the libraries that you want to auto-instrument. So we have that on our side. Now, the other thing is that just as test-driven development, or TDD, is about writing tests alongside your application code, we have observability-driven development, or ODD, which is the act of adding instrumentation as you write your application code. So this is where we want to instrument as you code. So by instrumenting as you code, you know exactly what to instrument, since the code is relatively fresh in your mind. And it also prevents new technical debt related to observability from being incurred, because you won't have to go back to your code to instrument it later. And on that note, make sure that application teams instrument their own code. I cannot emphasize this enough. Again, past life, have experience with this. Don't rely on an external team to instrument your code, because the application developers know their code best. They work on it daily and know what to look for when they troubleshoot. Now, it's so tempting to get a third party to instrument your application code when you're in a time crunch, but it will not end well. Do not go and ask the quote unquote observability team to instrument your code for you. That is not their function. And so to emphasize this, I will leave you with this very awesome clip from Liz Fong Jones.
Full grown-up software engineer, write your own damn tests, right? Like, so write your own damn comments, write your own damn observability annotations, right? Like, this is what will help you understand your code later. Someone else writing it for you achieves like very little of the value.
And I love this quote. This is from my old podcast on Call Me Maybe, where we had Liz Fong Jones as a guest. And I love using this clip often because it reinforces the things that I say about instrumenting your own code. So if you don't listen to me, listen to Liz. Now, the other thing is use OTel collectors. So although you can send your telemetry data directly from your instrumented code to your observability backend, you should use at least one OTel collector. Now, the collector acts as a central point for collecting and processing data from multiple data sources at once and exports the data to your preferred observability backend for analysis. So if you decide to change observability backends, you can send data simultaneously to multiple backends and decide which one you like best, just by updating the collector's YAML config file. And once you've selected your favorite observability backend, you just need to change the YAML in the OTel collector config. Yay. So with that in mind, some final thoughts to leave you with. Rolling out OpenTelemetry in your organization is not a trivial task. I won't pretend that it's going to be easy. It's not. There will be pushback. There will be people stuck in their ways who will be saying ridiculous things, but it's totally worth it in the end. I think having guidance for getting started goes a long way. Remembering to communicate, doing your homework, and following instrumentation practices will really, really help. And if you get stuck, hit me up. I am super happy to help. Also, highly encourage you to join the OTel end user SIG channel on CNCF Slack. It's called OTel-SIG -n-user. So be sure to join, ask questions, would love to continue the conversation. I leave you with some resources. I have a link to my blog on Medium. There are a number of OTel end user videos on the OTel official OTel YouTube. There is the blog post version of this talk that inspired this talk. And finally, my podcast, Geeking Out. Past guests have included Kelsey Hightower, Charity Majors, Hazel Weekly, and as Henrik said, most recently, Alex Bowden. I also want to mention that while I am not a great artist, I do make an excellent prompt engineer. I had lots of fun prompting AI to generate these capybara images. So all hail our evil AI overlord, Bing AI, powered by DALL-E 3. And finally, I love to leave my talks with pictures of my rats. I am a rat person, so these are 3 of my rats, Mookie, Buffy, and Katie. And so that is it for me. Until next time, peace, love, and code.
All right. Thanks, you, Adiana. I have indeed questions, but let's jump into the panel discussion so we can directly jump into the questions. All right, see you in a few seconds for the the panel discussion. Hey, first of all, thanks for taking the time and presenting. And I really like the fact that Yarden and Adiana did not cover exactly the same aspect, because Yarden was more in the general aspects of developer observability, and Adiana was more introducing OpenTelemetry. But I think I have almost the similar questions to you both. And Vijay, thanks. And I like I said, I have questions more about the aggregation. I had a lot of a question that was popping up when you were explaining the concept. And again, for all of you who are watching and listening, if you have any questions, drop your questions in YouTube, LinkedIn, whatever you're connected from, and we will try to answer to your questions. So Yarden, at KubeCon, there was an end user, I would say, that presented from TT Chat. So great talk, by the way. I will suggest to look at the recording. So he was in charge of the observability, and he wanted to. It's almost a question to Adiana as well, because he wanted to utilize the OpenTelemetry in general to improve the observability, so utilizing logs, metrics, and so on. So they went to the route. And they were trying to convince the developers, say, hey, you should start using auto instrumentation, or you should start instrumenting, or you should start building your metrics. And with all the effort of the world, I think I don't remember the exact ratio, but let's say it was like 60% of the project did their job and they were very happy, but there was still 40% of I don't know, bad students who doesn't want to change. So they had to come up to a solution to instrument those applications without the implication of the developer. So, how in you were transitioning about tools, but if we wanted, for example, to convince developers to, hey, go ahead and instrument your code with OpenTelemetry, what you suggested would make that also true, or the journey will be different from your perspective?
I think it's almost the same. Well, I think, first of all, we need to make sure there's time, because a big thing is you're saying, go ahead and instrument, but if it's not in the Jira, if you don't have a ticket for it, it's not going to happen. I mean, unless you're passionate about it, it's not going to happen. People want to get things done. And at the same moment, if you're not experiencing a problem that OpenTelemetry will help you with, then they're not going to do it. They're going to say this is more important, and there's always going to be something more important. So
it's going to be a bit like a champion approach, where you do one project that have instrumented, and then once they have an issue to resolve, they say, "Hey, we were more efficient, more effective, more productive, blah blah blah," and due to this, so go ahead and do the same thing.
Yeah, in my opinion, that's the best thing, especially since it sounds like it's really helping some other teams in the same organization.
Yeah. Okay. And what would be so in the case of the observability, and then Adiana mentioned really well, there's always like a central observability team who's trying to maintain and implement the platform. But in this case, we need developers. How would you recommend the observability team to convince the developers to involve them in the project itself, explain it? So the observability team having like Adiana mentioned, explaining OpenTelemetry through let's say through a conference approach for a talk, or how would you recommend that?
I think it needs to begin way before that, because if developers are part of the decision-making process, if before they decided on OpenTelemetry, they would have, taken a developer and sat through it, it would have, I think, made it for a better transition, because then it's exactly the same with the champion approach, right? And because observability teams aren't there just to do observability things and live in their own little bubble, but they're there to, at the end, their users are the developers or DevOps or other teams in that same organization. So it's important to have, in the same way that we won't implement a feature without making sure we have it's a good fit for our users, they should be doing the same thing. So it should be a conversation. And then once they make sure that OpenTelemetry, I'm sorry for saying this, but OpenTelemetry may not be what they need. It may not be the right solution for them. So they would want to make sure with the developers that it's still suitable for implementing it, and then it'll be easier to switch over to that.
Okay.
Make them insert it into their code.
So making them a part of the actual move. Okay. Adiana, Vijay, do you have any questions for Yarden?
No.
No?
Yeah.
Adiana? Not on your end. Okay. All right. So Vijay, same thing. If you have any questions from Yarden, please drop the questions. We will try to answer it as well live. We have about 10 more minutes for the panel discussion. So Vijay, so you mentioned about aggregation, and one topic that was very important in my perspective. You mentioned cardinality with the example of a container ID. Obviously, we're not going to query with a container ID. It's going to be very difficult. And for when I deal with this, usually I do like a scrap config, and I do relabeling or metric relabeling config to drop those labels and so on. So then when before they hit, they comes into the ingesting step is already filtering this piece. So I don't use aggregation. So in this particular case, you are referring to Cortex. You don't do that way. You put everything and then you run the aggregators to reduce this cardinality.
So the way that we do it, the container ID is a simple example, but a more concrete example to take into account maybe is that, like, say you have an application of say 5,000 instances that are there, and you don't really care about the pod level HTTP latencies. You want to only know at the AZ level, at the region level, and maybe at every individual kube cluster level. So for that, relabeling alone is not sufficient. You need to statefully route a given cluster's instance level metrics into a specific place where you do the roll up and then you ship it out. So for those kinds of use cases, streaming aggregations is useful, and like we over time have figured it out in a way that we don't use Kafka as well. We just bring the samples in memory, hold for a minute, roll up, and then just ship things out. So we felt that this this works for our business use case at least.
But it means that the data itself, the metric itself, is not hitting the time series database until it's been before the aggregator has
Correct.
removed or filtered out the data.
Yeah, that's correct. Yeah.
Okay, and this is like a core feature from, I think, Cortex has it, and Thanos has this concept as well.
I Thanos, I'm not sure. I think so. Yeah.
And is how is it, because you mentioned this the clustering and I mean the leaf, the zone and the root. How how is it difficult for, if there is anyone listening here, say, oh, I want to do this because it makes sense, it will simplify my journey with for the metrics. How big is the effort to come up to this architecture and have it stable and reliable in production environments?
Uh, it is doable for sure. If folks are interested in adopting such a pattern, we'd like to talk to them, because like if there are good enough number of people, one of the things that we would consider is to open source what we have. So that way it's more of a let's work together and solve the same thing, rather than you trying to do the exact same thing that we did, which took us a year or two to get here. But even in the absence of that, like I mentioned, like a combination of Bloom filters and being able to do things similar to Cortex, like the way that they have a ring to figure out where to route requests to and things like that. It is practically doable.
And in terms of storage, because it means that we need to, when you build the actual storage that is could end up in our cloud provider, you need to already imagine, okay, so I will have, let's say, this time series database that will be an average, let's say, I'd say 5 gigs, for example, which means I know I'm going to have 5 of them here, 5 of them here, 5 of them here. So then you're already thinking of how much storage you need actually to get this running as well.
Right. Yeah. So typically, if a use case needs to come on board, we evaluate the amount of samples they're going to ingest, their polling period, cardinality, and uh, basically we construct stateful sets with persistent volumes that have a fixed size. So we know that, okay, this is the upper number limit that it can handle. And our long-term store also, like, we make sure that we have enough capacity on the object store and things like that. Yeah. At least within eBay, we don't do cloud provider based hosting. We have our own data centers. So we need to make sure that we have the right capacity before we onboard someone on.
And my last question would be: so you said we can contribute back to open source. So did you actually modify Cortex? So you forked Cortex and you changed some few components of Cortex, or is it you are more referring to the actual deployment and the architecture that will?
Yeah, the architecture is similar. So we took the stock Prometheus storage engine as a package, and then we built ingest and query on top of that. We keep the same contract as Prometheus remote read and remote write, but when hopping between the layers, we have our own proprietary protocol that's gRPC based. But in concept, the rule manager, the alerting, storage, everything is just based on public interfaces that are there on the Prometheus project.
And questions almost similar to Yarden. How was the adoption? Because you build this platform, and then people obviously are going to use not only SREs or the observability team will use it. So how went the adoptions for this this platform?
So we actually took a very different approach to adoption, in the sense that most developers, especially on tracing and OpenTelemetry adoption, most developers were oblivious of OpenTelemetry. Within eBay, we have the concept of a managed framework. So everyone who's writing either a Java application or a JavaScript application that's powering the actual site, they use that framework. So we baked in all the observability that is needed to do standardized monitoring across all 8,000-ish applications that we have onto that, so that whether it be anomaly detection models or things that are required by SREs, like SLOs and whatnot, are all built on top of the standard observability that's there. And end users who want more, they alone basically pick up the instrumentation library and then start adding more instrumentation. Because at the scale, once you cross like 1,000+ applications, like chasing down every team, it's gonna take a while. So we go the hands-free approach by going through the framework.
Gotcha. Adriana or Yarden, do you have any questions for Vijay?
Not really. It was very interesting, though. Very far from what I do, so it was really interesting.
All right, so Adriana. So first of all, as usual, very nice graphic. I'm gonna ask you, where did you buy it? Because at the QCon you had the same templates. I say, she may have built that same template. So I will ask you privately where you get that. It was interesting. So you mentioned a couple of things, and you mentioned that don't go to the auto instrumentation by default. Because maybe you will have too much garbage produced and very hard to utilize this. So when we start instrumenting, it's very hard to figure out how much details do I need, or because we naturally we try to produce lots of things, and then we suddenly, after a few releases, say this I'm never going to use it, it's just waste. So how would you recommend to new organizations that are going to make the step into OpenTelemetry on how they should do the instrumentation, and how they should clean up the instrumentation to select only the golden traces, spans from the traces?
Yeah, sure. So just to clarify, I do still recommend that like you start with auto instrumentation, because it's the lower barrier to entry. And I think when people get to experience auto instrumentation, they're like, okay, this is doable. I think I got it. But then they will soon discover that there's a lot of crap going on. And I think it ends up being one of those iterative processes where you just sort of have to start sifting through the traces being produced and just realizing, okay, is this of any use to me? Is it of no use to me? I think also this is where it's so important to emphasize the need. Like, observability isn't like a one team thing, right? I see it as it being a team sport. So you can't have just like, it might be that your SREs are probably the team that's going to be doing that troubleshooting for you in production, but the instrumentation has to start somewhere, right? And it's got to start with like your development team. And so by getting them involved from the beginning, and even getting them to use OpenTelemetry to troubleshoot their own code, and taking it a step further and involving QAs in it as well, where basically instrumentation becomes a quality gate. So then, you're not going to start QA until you've instrumented your code, and then QAs can take that information, and when they're running their tests and trying to figure out what's going on, they can use the instrumented code to basically say, okay, I know what the problem is. Here's the fix, right? Because the developers have instrumented properly. Or on the other side, I can't figure out what's going on in spite of the fact that you've instrumented this code. We need to tweak your instrumentation. So then everyone's getting involved. And then I think on the other side too, like by the time it gets to the SREs, they are the ones who are going to be coming up with service level objectives for the application. Well, those are informed by the telemetry that you emit, and specifically the metrics. And if you've correlated your metrics to traces, then by the time like you get that alert on the SLO, you know exactly what you're going to start looking for in terms of troubleshooting. Now, that being said, coming up with SLOs is also an iterative process. So it's going to take some time before they can sort of sort out what makes sense in terms of setting your SLOs. So then this becomes like this iterative conversation that you have like with your developers, your SREs, and your QAs.
Okay, and I also was wondering, because you didn't mention about it, is about the sampling. Sampling, because OpenTelemetry is you have to somehow either set it at the client level, so at the code level, the level of sampling you want to apply, or you can put it on the collector. So what would you recommend? Because as an end user, I mean, for a new organization, sometimes the samplings is something that they usually forgot is they don't understand the concept and the importance of it. So what would you recommend? Would you recommend do it from the client or leave the the observability team control the sampling from the collector perspective, or what's the best option?
I think the main thing is getting people in the habit of like relying on the collector and not doing all the configs from the client site. So I guess that would mean that I would say the quote unquote burden goes to whatever team is managing the collector, but it can't be that conversation happens on an island, right? Because they might not necessarily know, well, what's important for you in terms of sampling, right? So that's a conversation that has to happen with the development team. But I would, I would highly discourage like doing stuff on the client side, just because there's not nearly as much flexibility as you would get with the collector. Like it might be an initial like, oh, let's see what OpenTelemetry can do. Let's send stuff directly from our application code to the backend. Cool. But it shouldn't go beyond that. Like then it's like, let's actually try to mimic a more realistic like production scenario.
And Vijay, you mentioned the way your framework you implemented at eBay. Do you already in the framework? Where do you define the sampling? Is it your team in charge of sampling the traces, or is it already packed in the framework?
We with the framework team decide what the default sampling should be. So we pick 2% as the global sample limit. But over time, we want to get to more adaptive sampling where teams can ask for more and we are able to push it into them. For us, at least, the traffic patterns are fairly known that we don't really need to have 100% samples for everything. It's fairly cost prohibitive. So we do a 2% sample first, and then on storage, we do a subsequent sample that's retained much longer. So we do a combination of both head and tail.
But this journey you took with the numbers you made, how long did it take to figure out, oh, let's come up with those numbers?
So I think the first step was to decide on what the instrumentation is that needs to be baked in. So for every client, server, and database call, we instrumented the spans on the framework, and after that we did a progressive ramp, saying that starting at 0.01% across all applications, and then we ramped to 0.1, 1, 2, and every step we asked ourselves, do we need more, do we need more, do we need more? And right now we are at 2 and we haven't felt the need to go higher, but there are a few flows that don't have enough traffic, but the adaptive sampling has a nice way in which you can say that for this particular operation on a given service, make sure to sample higher. So that is something that we are exploring.
Okay, thanks. So I'm looking at the time. I have other questions, but I think it's already 1 hour and 50 minutes, so it's a bit long for a live stream. So first of all, thanks Yarden, thanks Vijay, and thanks Adiana to taking this time to present, taking time to be part of this live stream. So thanks a lot, because otherwise, without you, this session doesn't make sense, to be honest. So a big applause for you guys, all of three. The recording will be out there on YouTube. So if you want to rewatch, if you don't have the chance to be part of the live, just look at YouTube, and you will be able to. I will add some timestamps. It will be easier to consume the recording for sure, but I will do that probably tomorrow. All right. So if anything else, I would like to thank everyone who's been connected to this session for an hour and more. And we will organize the next Observable lightning talks probably around June, before July at least. So keep posted. I will promote the next event soon. All right. Thanks, everyone. And of course, if you enjoyed this content, don't forget to like and subscribe to the channel. So thanks for the speakers. Thanks, everyone. And see you soon for another Observable lightning talks.
Thank you so much.
Thank you.
Thanks.